We're here with Evan from Popoto Modem. And Evan, you're going to tell us about a new product you're launching here, which is the SeaSignal. What is it and who's it for?
So the SeaSignal is an AI-enabled acoustic monitoring device that has edge signal processing. And so this is designed for anybody who needs to record signals underwater.
And what kind of use cases, what kind of applications do you see the SeaSignal being used in most?
So the use cases for SeaSignal are quite broad, but a few examples could be environmental monitoring, say listening for whales or other underwater creatures. It could be for doing environmental studies, say for windmills. It could be for harbor defense in terms of like listening for boats and activities, and just in general any other application that needs underwater acoustic monitoring.
Two words I want to pick up on there, edge and AI. Talk to me about the importance of the processing at the edge, and then just tell me what role AI plays in what the SeaSignal's doing.
Right, so most in this market is typically called passive acoustic monitoring, but we're kind of taking that to the next step and removing passive, and we're doing detection of signals, and so like one example we have is being able to decode acoustic modem signals from not only our Popoto modem, but other open standards like Janus and Forces. In terms of edge processing, we can actually run AI models directly on the device itself. And so if you train the AI model to look for certain things that you want to look for, like a specific species of whale or motorboats, and you can run that detection directly on the device.
So on-device, edge, AI inference here. That sounds fantastic. You've got a demo here that you can show us just so we can see a bit of this in action and conceptualize it a little bit more, yeah?
Yes, that's right.
Let's take a look. What have you got set up for us, Evan?
So what we have set up here is our PMM 6081 development kit. And so in this demo, it's acting as a transmitter. And so the modem is transmitting from this transducer right here through the air, which is less efficient than water.
Yes.
And then we are receiving that signal on the SeaSignal device here. And so the hydrophone is down here at the end, the device here is in the middle, and up top we have a dock mate, which is used when you've got the product out of the water and you can communicate to it with Ethernet and control the power.
Okay.
And what we have set up here is being able to send a message from our Popoto modem over here, and we send that message, and then if we look over here on the Popoto SeaSignal, we can see the recorded message, and we can see the message annotated on the screen. And so right now we're set up with Popoto, but there's other acoustic standards that this can decode as well, like Janus and Forces.
So I don't know if the microphones picked that up, but when you pressed send message on here, coming out of this transmitter, there was a kind of high frequency sound, encoded message that was then transmitted through the air, not through the water, which is where it would be used, to your receiver here. And this is essentially your underwater microphone that received that. Then you decoded that, and then across the spectrograph at the top there, that's where we saw that decoded message. That works for this message, but what you're saying is that if you're listening for speedboats or whale sounds, it would also be able to detect, infer those using the on-device AI models as well.
That's exactly right.
Right, okay, impressive stuff. So talk to me. This device here is going to be submerged for long periods of time, of course. In terms of battery life, in terms of storage capacity, because you're recording a lot of data here, just talk to me about those numbers, those speeds and feeds.
Right, so we've done a lot of work to pack a lot of battery power into this to enable up to 24 hours of runtime on a single charge.
Okay.
We've also optimized the device to be able to recharge very quickly in less than 3 hours, enabling a quick turnaround on a deployment. In terms of storage, we have up to 4 terabytes of storage capacity internal, and depending on what sampling rate you're working at, that can be hours or even days of data.
Yeah. And then interoperability with other systems as well. How will this work with other types of technology that you may already be using?
Right, so we can, in terms of acoustic message decoding, we can decode Popoto modem messages, we can decode Janus messages, we can decode Forces messages. But with the addition of the AI server, you can search for basically anything you need to train it on. And we also have a framework to be able to, if a customer has their own sort of message or anything they're looking for, we have a framework that enables the SeaSignal to pick that up as well.
And then final thought, I guess, Evan, is what is it that sets apart the SeaSignal from other technologies that may already be out there right now?
Right, so I think this is where, with the standard passive acoustic monitoring, we've improved that in terms of battery life and internal storage, and also gigabit Ethernet for offloading that data very quickly. And that's kind of like the standard features that are better than things out there on the market. But the addition of edge data processing and AI, embedded AI, I think really kind of changes the market category from passive acoustic monitoring to really smart acoustic monitoring.
We'll leave it there for now, Evan. Thank you very much indeed for chatting us through the SeaSignal from Popoto Modem. All the very best with the launch, and thank you for joining us here at Oceanology International.
Thank you very much.